Hi, this is Andrew. Thanks for joining me. Today's video covers IPv4 subnetting in what I hope is a very simplified way. So let's see if I can make that work for you. So first thing I want to do, we're starting out with 192.168.1.0, and I'm going to insert a table here, and we can look at this table as a number line. Under this table, we have numbers ranging from 0 to 255. And that's because those are the numbers that we can represent with this fourth octet. Now, nothing aside from this fourth octet matters, because when we say /24, what we're saying is 255.255.255.0, and that's our subnet mask. And this 24 is because we have 8 bits on this octet, 8 bits on this octet, 8 bits on this octet. 8 plus 8 plus 8 is 24. So we have 0 network bits on this octet because we don't have any more numbers beyond the 24. We're going to get into putting something else there. But for now, all we have is 0 to 255. And if I create a chart under that, let's see if I can make it do what I want. I'm going to insert. This time I'm going to do 4 by 2 because this covers what we always need to know about a network. The first thing we need to know is the network ID. The second thing we need to know is the first usable address, and then the last usable address, and then the broadcast. So our first thing is our network ID. We already know our network ID. We got it. We haven't subnetted yet, so it's easy to say, here's our network ID. I'm just going to paste it into here. Now, first and last, I'm going to come back to those because I frequently find it's easier to do those, to get the network ID, broadcast ID, and then fill in the first and the last. Broadcast, it is 255 because it is the largest number we can get in this network. So since we're only looking at this fourth octet, the largest number we can put there is if we put a 1 here, and a 1 here, and a 1 here, and a 1 here, all the way across, what we're doing, this is converting this binary number of all ones into decimal. And by doing that, we just say 124 plus 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, and that equals 255. And if you don't believe me, fingers, toes, whatever you need to do to add it up. So now what we're looking at is our first. And our first is really just saying our network ID, which is all zeros, with a 1. That's the first one. We just add 1 to the network ID. And you convert this from binary to decimal, and that number is 1. It's actually 192.168.1.1. Now the last is we take 1 away from the broadcast. It's easy to take 1 away from 255, but we'll go back to where we were. 1, 1, 1, 1, 1, 1, 1. This is our broadcast, and I just turn this into a 0. And we add 128, 64, 32, 16, 8, 4, 2, and we get 254, which is 1 less than our broadcast. So we've just figured out the network ID, the first, the last, and the broadcast. And frequently you're going to need the network ID for routing purposes. Frequently you'll need the first ID. That's going to be most likely your router interface. You want to know where things are. And that's the most common Cisco question that you'll run into is, any Cisco questions you run into can be answered with these, with the first, last, broadcast, everything there. So next thing we're going to do is we're going to say, what if we want more than one network here? And we can do any number of networks within a certain range, but I'm going to just copy this down and say, I want to do something new. I want to now create 2 networks. So in order to do that, I need to take this last octet and break it into pieces. So what I'm doing here is I'm going to say, instead of what I have here, I'm going to split cells and make 2 columns. Now I have this going on. And if I go to here, this is going to end at something. And it's going to start at something else. It's actually going to end at 127 and start at 128. 128. But we need to figure out why. You can't just trust me for that. So let's get rid of these numbers so we can figure out what they're going to be. So in order to do this, we can't have a 255.255.255.0 subnet mask anymore. We will break this into binary and figure out which portion of it is going to be our network and which portion is going to be our host. Now, in order to get 2 networks, we need 1 more network bit. And that means that when we do numbers, when we convert this number to binary, it's going to be 0, 0, 0, 0, 0, 0, 0. And what we need to do, since we added a 1 here, we now have a /25 address. Because we have 8 plus 8 plus 8 plus this 1 right here. And now in this case, we're using a combination of binary and decimal. And I know it looks a little confusing. It looks a little more confusing if you're using all decimal. And if you remember, none of this matters. We're going to make it red. We're going to make it anything that's red, we're really not paying attention to because we're just copying things down for the most part. So we now have 1 and 7 zeros. So that means that our 2 networks are going to be 192.168.1, and then we do this one in binary. And really, what we're looking at is this 1 binary bit, because that is part of the network now. Everything else is part of the host. So what we do is we say we can have a 0 there, and we can have a 1 there, because as binary, those are our only options. And we do a /25. So we just created 2 networks, but we don't know what they are yet because we didn't do any kind of math. So let's make that red. Now, the first bit in both of these is part of the network address, and I'm going to try to make them green so they stand out a little bit. Green. Green. And then the unhighlighted portion, and we'll actually make this green, and the unhighlighted portion, that references the host bits. So in order to figure out our same thing we did the first time, we need another chart, except in this case we had 1 network. We're going to need 2 networks. So I'm going to insert a 4x3 table. And we're going to put our network ID first last broadcast. Control C, Control V. And here we have our first network is 192.168.1.0/25. That's what we have here. And we know this because if we put all zeros up here, 0, 0, this is what we're doing. We're just converting this number into decimal. And all zeros is all zeros. Now for this network, this is our second network. We're just putting that there and converting that into decimal. And that tells us that our next network is 192.168.128/25. Now we still need to figure out first last broadcast. So what we could do to figure out the broadcast is we just say we're going to take this binary section right here, and it is all zeros. We're going to make all of the host bits 1s. 1, 1, 1, do a double space, 1, 1, 1, 1. And we just put these numbers up here. That's our broadcast. The broadcast is defined as putting all 1s in the host bits. So we can go here and say, well, if we do 1, if we do a 0 on that bit, because that's network, we can't change that. Now we set all of our host bits to 1. If we add 64 and 32 and 16 and 8, 4 plus 2 plus 1, we get 127. Now on the next network, we're doing the same exact thing, except this bit here, this green bit, is a 1 on this network. So we just now go here, 1, 1, 1, 1, 1, 1. I think I had an extra space there to make it look a little better. And in this case, this is all 1s here. That's 255. So we now have our network ID and our broadcast ID. And if you remember from here, network ID is, the first address is 1 more than the network ID. The last address, just like here, is 1 less than our broadcast ID, 126. Now our first on the next network is 1 more than 128, which is 129, and our last is 1 less than 255, which is 254. So we just converted this one network into 2 separate networks with subnetting. Couple of questions here. First is, how many networks did we have? And let's undo that. We kind of already can see that. It's easy to figure out, it's easy to see, but let's do some math on that. What we do is we say this is 2 to the n power. And what that is, let's make this bigger so you can see it a little easier. In this case, n is the number of network bits. Equals 2 to the n. So what we have, let's go here. What we have here is 2, and the number of network bits is 1, because that's all we took here. We only have 1 of these green spots. So 2 to the first power is, let's do this. 2 to the first power is 2. Now, the next step is hosts. And the math on it is similar to, and we'll say to the n power minus 2. Now, in this case, n is not the number of host bits, of network bits, it's the number of host bits. So we had 1 network bit, and that told us how many networks. We have 7 host bits. So we need to now do 2 times itself 7 times. So 2 to the 7th. Ooh. Let's try that again. 2 to the 7th power minus 2. And what does that equal? So we'll talk about why it's 2 to the n minus 2 in just a second, but let's figure out what it is. We start with 2. Times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. Times 2 is 128. So that's 2 to the n is 128. So all we did is we started with 2 and we said times 2 is 4. And then we took 4 times 2 is 8. That's as complicated as we get. We got to 128. Now we take 2 away from that, and that's 126. Why do we take 2 away from that? Because we have this network ID and this broadcast ID. So those 2 numbers are used up. Those 2 numbers are not available for host addresses. So our number is 126. And if we look at this, our first address is 1, our last address is 126. So we have 126 addresses available. And that's just the way the math works on it. So what do we do next? Let's say we wanted to, instead of going with 1 host bit, we wanted some other amount. And if they asked us in a complicated way, they might say, we need 4 host bit. We need 4 networks. In order to get 4 networks, we're basically starting with this last number and saying, how many network bits do we need to have 4? So let's do that over here. We're starting with 192.168 1.1.0/24, and we need 4 networks. And then we're going to figure out what each of the networks is. So first step is how many bits do we need? And if we just go back to this equation right here, if we have 1 network bit, that's 2. If we multiply 2 times 2, that gets us 4. That's what we're looking for. And that took 2 network bits to do that. And so we're going to say we're at 192.168.1.0/26. And if we look at this, we can kind of figure it out the same way. And I'm not going to do the red part this time. I'm only going to focus on the octet we care about. So our first network, and I'll put the 128. Actually, I will copy and paste that. So I'm going to put this here so we can put all of our 4th octet network addresses. So our first one, pretty simple, just like last time. Now, remember, we are only looking at, these are our green bits right here. So our next network has to be just increasing this by 1. We keep all of these as 0. The next thing we can do after 0, 0 is 0, 1. I think we have too many lines there. And then from there, it's all zeros. And then our next network is, when you're counting in binary, if you add 1 to this, because that gets us to our network, 1 plus 1 is 0, and we carry the 1. So that's 1, 0. And then all zeros. And then we have 1, 1, and all zeros. So this is our next network address. These are all of our network addresses. And let's see, the first 2 bits in each one, there we go, are the network. The rest of it is the host, are the host bits. So those host bits, when they're all 0, that's the network ID. And all we need to do is say, what does this equal? So this equals 0. This equals, there's a 1 in the 64 column, and that's it. So that equals 64. This equals a 1 in the 128 column, so it's 128. And then this one equals 128 plus 64, which is 192. These are our 4 networks. So if I just go back to, I'm going to create a new table so we can get our first, last network. Insert. We need 4 by 5 because we're putting our network first, last, broadcast. So our network, and again, I'm not even, I will put 192.168.1.0, and remember, we went to a /26 because we have 3 octets with 8 bits each, plus 2 more bits. So 8 plus 8 plus 8 plus 2 is 26. So we have a 26 there, and here it's 192.168.1.64, which is this network here, /26, and 192.168.1.128 /26, and then the final one is 192.168.192. .1.192 /26. So now we figure out the rest of it. We just fill in the chart. If you noticed here, The broadcast is one less than the next network. And we only see it in one column here, but that always applies. So if we need the broadcast address of this first network, we just look at the next network. Next network is 64. That means broadcast is 63. The next network here is 128. So our network address is 120. Our broadcast address is 127. We have 192. One less than that is 191. And then our last one is going to be all ones, which is 255. 255. And we could also calculate it out here. If we said turn all of these into ones, that is 32 plus 16 plus 8 plus 4 plus 2 plus 1. That's our 63. If we turn all of these into ones in this column, that gets us to 127. All of these into ones in this row, 191. All of these into ones in this row, that gets us to 255. So then we just can, again, fill in all of the gaps. This one is 1. The last is 62. And this one is 65. The last one is 126. This one is 129. Last one is 190. This one is 193. And the last one is 254. Now if I go back to this 2 to the n minus 2, 2 to the n I can really already figure out. I don't even need to write it down. 2 to the second power, that's 2 squared. That's 2 times 2. That's 4. 2 to the n minus 2 for the number of hosts. In this case, we have 6 host bits. So that's 2 to the 6th. Let's turn that off. Minus 2. And let's make it a little bit bigger so we can see it a little bit better. No, that's not quite. Let's do that, I think. So, what do we come up with here? We go equals 2 to the 6th power, because we have 6 bits right here. And each bit has 2 possibilities, 0 and 1. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. That's my 6th finger here. So 64 minus 2 is 62. And hey, look at this. We go from 1 to 62. There are 62 addresses. And if you counted out or did math on these, you would find 62 in each network. So that gets us through any way we want to do it. If we were working with 3 bits, we'd do here, 4 bits, 5. The only problem is, it can be, if we had, say, 5 network bits, how many networks would that be? That's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Do we really want to draw out 32 rows of ones and zeros? That seems kind of unnecessary. So there is I don't want to call it a shortcut or a trick, because it's just we're taking advantage of the math that's there. But if you look at this, when we say /26, what we're saying is our subnet mask is 255.255.255. In this case, I'll do it in binary first. 11 0 0 0 0 0 0 0. This is our subnet mask. We're saying we have 2 of these bits are for the network. So if we do our subnet mask here, that is 1 1 0 0 0 0 0. And if you look, that means that this portion of our subnet mask is for networks, the rest is for hosts, and we do the math on that, and our subnet mask is actually 192. 255.255.255.192. Now, if you can figure that out, you can get to this being what your subnet mask is. And something interesting happens here. Since this is the number we're counting with, let's go light blue, kind of visible. So that's the number we're counting with. If you look here, we go 0, 1, 0, 1, 0, 1. Not quite as many. But what we're doing is we're counting by 64s. Now, if we look at our network IDs, 0 plus 64 is 64, plus 64 is 128, plus 64 is 192. So we can count by whatever this last bit is in our subnet mask. So if I come up with another situation where instead of where I go, let's make this back again to 12, we have 192.168.1.0/24. And we need to break it up into the example I gave of 32 networks. So in 32 networks, that means, let's copy that. Let's copy instead of cut. So I put this back down here, except in this case, we're going to go further. We're going to say we need 5 bits. So those 5 bits are all green. And now this number is no longer the one that matters. We have 1, 1, 1, and it is this one that matters. This is the one we're going to be counting by. So I'm going to go, I'm going to make that one the light blue one. Now if this were our situation, we would have 192.168.1.0 is our first network, slash 24 is what we started with, and we added 5. So we're at 29. Now we go here. If we want to do our networks now, 192.168, I won't even create a chart for it. 192.168.1.0/29. Our next network is 192.168.1.8, because we're just counting by 8s right now. .8/29. And then we would keep going. So I'll do this. Control C. I'm going to just paste a bunch of them in there. Oop, too many. So 8 is our first one. 8 plus 8 is 16. That's our next one. 16 plus 8 is 24. And then 24 plus 8 is 32. 32 plus 8 is 40. 40 plus 8 is 48. Let's try again. 48. 48 plus 8 is 56. And we can just keep going and going and going. All we have to do is know that we're counting by 8s. Then we want to have our, we'll leave room for our first, our last. Our broadcast on this one is 7. Broadcast on this one is 15. Broadcast on this one is 23. And everything else fills in as much as we want to. So first address is 1, last address is 6. First address on the second network is 9, last address is 14. And we'll just do the third one. First address is 17 because our network address is 16. Our last address is 22 because our broadcast is 23. So now let's just do this calculation one more time. I'm going to copy it and I'm going to create a little more room by doing that and see if I can squeeze it in down here. And let's do one more here. So we have a new n. This is how many hosts we have left. Now, if we want to know how many networks, we're 2 to the n, and n is 5. So we do 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's where we came up with the number to begin with. We have 32 networks. How many hosts do we have? 2 times 2 is 4, times 2 is 8. Minus 2 is 6. 1 through 6 we have here. 9 through 14. We can keep going and going. We have 6 hosts on each network. Now, because there are 32 networks, obviously you could write it out 32 times. Normally in this situation, what will happen is you'll get to a point where you know this is the network I need to worry about. You'll have a question like, what is the what is the first address in 192.168.1.16/29, or what is the last address in that network, or are these two computers on the same network, or these two IP addresses? Or it could even be something like, is this computer going to send this message to the gateway? Is it going? What address will ARP get? What layer 2 address will show up on this frame at this point? And understanding that it's communicating with something on a separate network, which means it's going to be its first first address on the network. These are just all ways of asking comparable questions and looking for understanding on both subnetting and other aspects of network communication. So this is really the simple aspect of it. We can take it a step further, and that is kind of discussed in my other video that covers variable length subnet mask. Feel free to take a look at that. But this is really foundational, critical to understand, and common in network troubleshooting, but also common in Cisco exams you might run into. So really, really important to understand for so many reasons. So that's all I have for you today. Thanks for watching.